Statistics 3, hypothesis testing, type 1, population proportion. So what we want to do here is break down our hypothesis test into 4 parts. So our first one is always to state our hypothesis. And we have to make sure that we're stating that clearly. So there's 2 ways in which you can state your hypothesis, your null hypothesis and your alternative hypothesis. You can do it in sentences or you can do it in terms of your population proportion. So if we look here at this question, we can see that it is thought that 30% of a certain kind of apple seed will germinate. In an experiment, 85 out of 300 seeds germinated. What conclusion can be reached at the 95% confidence level about the true population proportion of seeds that will germinate? Clearly state your null and your alternative hypothesis. So they always like to remind you to state your null and your alternative hypothesis in these questions, and even in the Lebenswert they tend to do that all the time as well. So that's always going to be our step 1. So we start by stating our null hypothesis, which is H0. And I'm going to state my null hypothesis in terms of my population proportion. So I'm going to state that the population proportion is equal to 30%. And of course you can state that as equal to, P is equal to 0.3 either. That's up to yourself. And then my alternative hypothesis is that there is a change. So therefore that would be that it is not equal to 30%. Or again, we could say that is not equal to 0.3, right? So what does that mean? It means that there is no change in my null hypothesis. And the alternative is that there is a change. So we now have to test this claim. So to do that, our second step is then to find our sample proportion. Okay, so to find p hat, our sample population proportion, we're using x over n. And remember, that's not in your tables. You need to remember how to do that off by heart. So what is x? Well, x, we are told, is that 85 out of 300 seeds germinate. In other words, 85 seeds are successful, so that's our x value, and n is our sample size, which is 300. And therefore, our sample population proportion is 85 over 300, which simplifies down to 17 over 60. Now, if I was to change that to a decimal, it's a bit messy, so I'm going to keep it in fraction form. Okay, so my next step then is to set up my 95% confidence interval. And I'm going to do that for my sample population proportion. So that's my sample population proportion plus or minus my margin of error, which is 1.96 times p hat 1 minus p hat over n. Remembering that the second part of that is in your tables, but the whole formula itself is not in our tables. And of course, if we're trying to remember what page is that on, it's our page 34 for our standard error of the population proportion. And that's only for the standard error part, okay? So you won't get the times 1.96 and you won't get the plus or minus the sample population proportion. So again, you need to know that off by heart. Only this part of the equation can be found in the tables, whereas the rest of it is not. Okay, so let's separate that out. So that's going to be our sample population proportion minus 1.96 times the standard error of the proportion is less than or equal to is less than the true population proportion, which is less than our sample population proportion plus 1.96 times the standard error. Okay, so if I sub in my values, well, what did we say our sample population proportion was? It was 17 over 60. So we have 17 over 60 times 1.96 times the square root of 17 over 60 times 1 minus 17 over 60 over our sample size, which we said was 300. And then we have 17 over 60 plus 1.96 times the square root of 17 over 60 times 1 minus 17 over 60 all over 300. Okay, so putting all of that into our calculators, then what do we get? So on the left-hand side, then that gives us 0.2323. Okay, and less than P, which is less than, and on the right-hand side then we get 0.3343. So this is our 95% confidence interval for the population proportion. So of course our question was given to us in terms of percentages. So 30% of a certain kind of apple seed will germinate. So therefore I'm going to write my answer as a percentage so that we can compare the two. So we have 23.23% less than P, which is less than 33.43%. So either of these answers are correct. Okay, they are both your 95% confidence interval. So what we're stating here is that we are 95% confident that our true population proportion lies within the interval of 23.23% and 33.43%. In other words, that's what we're expecting for a number of seeds that are actually going to germinate. So now what we can do is we can test our hypothesis claim. So in other words, we're going to draw our conclusion. So what can we state? Well, let's go back and we look and we say our null hypothesis was that there is no change. In other words, that the population proportion is going to be 30%. And the alternative hypothesis is that there is going to be a change. In other words, that the population proportion is not going to be 30%. So how do we relate that to our 95% confidence interval? Well, we can see that 30% actually lies within the 95% confidence interval. And therefore, what are we going to do? Well, we're going to fail to reject our null hypothesis. So we state 30% lies within our 95% confidence interval. Hence, we fail to reject our null hypothesis. And then we say, i.e., the true proportion of seeds germinating is unchanged at 30%. Okay, so what I'm going to get you to do now is go to your textbooks, and I'm going to get you to go to page 159 in your books, and you're going to do question 1, question 2 and question 3. So that's page 159, question 1, question 2 and question 3.